Hi class, this video goes with section 5.2. We're going to be talking more about angle bisectors and perpendicular bisectors, but we're going to talk about their intersections today within triangles. So this first page I'm not going to talk too much about, it's mainly just the vocabulary. So you do want to get this out of your book before we go through those examples. But one big word to note is concurrent. Concurrent is when three or more lines intersect. So when that happens, we have a point of concurrency. So talking about angle bisectors and perpendicular bisectors, those are all concurrent within a triangle. So we call that point of concurrency the circumcenter for perpendicular bisectors, and we call it the incenter for angle bisectors. The reason for that is a circumcenter, if I were to draw a circle with this as my center, it would touch all the vertices of the triangle. I'm sorry, my circle is not very perfect there. And same thing here, it would touch all the vertices of my triangle. So what this does is it creates a circumscribed circle is what we would call this. So a circumscribed circle is something that contains a shape, but the shape's vertices or points touch the edges of the circle. So the circumcenter is that point here. It creates that circumscribed circle. So if you think about a circle, its center is the same distance away from every point on the outside. So if the vertices are the points on the outside, that means those distances are all the same. So that's what the theorem states. If I have a circumcenter, which is where all my perpendicular bisectors intersect, it's the same distance away from B as it is from C, as it is from A. So all those distances are equal. The incenter works similarly. This is the intersection point of all the angle bisectors. Although instead of forming a circumscribed circle, it forms an inscribed, so meaning it's inside the shape, but it's touching every side. So inside the shape, touching every side. Again, sorry about my imperfect circles. And here, touching every side as well. So again, thinking about a circle, that center is the same distance away from every point on the outside. Those points are the sides of my triangle. Now, to touch the side, remember we talked about this in one of our earlier videos, but the sides, that distance from the circle center to the side is the shortest distance. So it's going to form a perpendicular. So if you look at this picture on here, point P is the incenter, that point where all the angle bisectors intersect. It is the same distance away from each side. Now by same distance, we mean the same shortest distance. So if I look at the perpendicular here, that's the shortest distance from P to this side. So I went ahead and added an additional letter there to mark that point. Same thing with AB. The shortest distance from P to AB is straight down where it forms perpendicular. So those distances that are the closest to P, PY, PX, and PZ are all equal. That is where my inscribed circle would be touching. Okay, so we're going to use those two theorems to solve some problems. Okay, so in number one, I'm told that these are all perpendicular bisectors, meaning, or sorry, not all of them. KZ is a perpendicular bisector, meaning that's 90 degrees and it's bisecting. LZ is a perpendicular bisector, so that's perpendicular and bisecting. And MZ, so perpendicular and bisecting. So the perpendicular bisector, so this is my circumcenter, because it is where all three of those intersect. So the circumcenter theorem says that Z will be the same distance away from each vertex. So that means that GZ is the same as HZ is the same as JZ. Okay, so I'm going to use all those congruency markings to help me find these missing blanks. So ZH. So ZH is the same as JZ, which is the same as ZG. So I am given that this one is 19.9, so all of these are 19.9. So ZH has a length of 19.9. GM is here, and since this is a perpendicular bisector, MZ, and it's being bisected, this half of 14.5 is going to be the same as this half, so GM would also be 14.5. Okay, find the circumcenter of this triangle, and it's giving me some vertices. So I'm going to go ahead and plot these. So I've got O is here, 0, 4 is where I have S, and negative 6, 0 is where R is. So if I connect these, I'm trying to draw them dark so you guys can see a little bit better. Okay, so the circumcenter. So this is where I have the intersection of perpendicular bisectors. Okay, so perpendicular bisectors are going to be at the midpoint, and they're going to be perpendicular to this side. So technically I have 3 in a triangle, but if I can find where 2 of them intersect, the third one's going to intersect at the same place. So if I want to find the midpoint here, it's 6 long, so my midpoint's going to be at negative 3. And this is a horizontal line, so something that's vertical would be perpendicular. So if I draw a line right here, this is my perpendicular bisector. Okay, now I'm going to have a perpendicular bisector to this side as well, very easy to find because it's 4 tall, so my midpoint is going to be at 2. And this line is vertical, so a horizontal line would be where it forms a perpendicular. So perpendicular bisectors here. And I could do this third side as well, you guys, but it's not necessary because where 2 of them intersect is going to be the circumcenter no matter what. So the circumcenter of those intersections is at negative 3, 2. So negative 3, 2 is the points of the circumcenter. Okay, last example here. With angle bisectors, JV and KV are angle bisectors. So JV is bisecting angle J, and KV is bisecting angle K. All right, so those angles are congruent because it's a bisector. And remember, where those intersect is called the incenter. So V is the incenter. And the incenter theorem says that the incenter is the same distance away from each side. So again, the shortest distance, which would form a perpendicular. So this distance and this distance are all going to be the same. Okay? All right, so answering these questions, find the distance from V to KL. So that's that straight across distance, which remember has to be the same as these two as well, which was given to me as 7.3. So the distance from V to KL is equal to 7.3. They also want me to find the measure of angle VKL. So VKL is this right here. Well, I don't know the whole thing and I don't know this one, so I don't quite have enough information just using this angle, but I do have a lot of information about the triangle as a whole. So I know that this angle L is 106. This piece of J is 19, so this one would also be 19 degrees. So all of those together have to add up to 180. So I could say 19 plus 19 plus 106 plus, and then I've got kind of 2 x's there, right? Has to equal 180 by the triangle sum theorem. So we can add these together and solve. So I get 38 plus 106 is 144. So 144 plus 2x equals 180. Subtract 144 from both sides. So I get 2x equals 36. Divide by 2. X is 18. And remember, x was representing that angle VKL for me. So VKL is 18 degrees. All right, guys, there's a couple examples with those theorems. Hopefully that helps you on that 5.2 homework. Thanks for watching.